Welcome to Amii. As one of Canada's preeminent centers of artificial intelligence, we thrive in our role bridging world-leading research and industry. Join us as we cultivate scientific excellence, develop talent, and coach businesses through AI adoption.
Hello, and welcome to Machine Learning in the Real World, presented by the Alberta Machine Intelligence Institute. We are very excited to be a part of Startup Week here in Edmonton, both as presenters of this session, as well as sponsors of the AI and machine learning track here this week. Before we get started, we want to acknowledge that the land on which we gather is Treaty 6 territory, a traditional meeting ground and home for many Indigenous peoples, including the Cree, Saulteaux, Blackfoot, Nakota Sioux, and home of the Métis. We also acknowledge our treaty obligations and are committed to living in accordance with collaboration and friendship. As we're on YouTube today for this session, feel free to post any questions or comments that you might have right in the chat on YouTube, and we can bring them up on the screen. We might answer them during the presentation if we see them then, but we definitely have time at the end for questions as well. So don't feel like you need to save all your questions for the end. Put them right in the chat as they come up and as you're thinking of them. Kicking off today, we have two facilitators. So myself, I'm Adam. I am the product owner of the startup stream here at Amii. And we have James Bell, who's our machine learning scientist for a startup stream. We're both very excited to present and to be here with you today. And if you have any questions, like I said, feel free to let us know throughout. So how do we think about AI and machine learning here at Amii? Well, this quote from Rich Sutton, our chief science advisor, does a really good job at summarizing it. So we think about AI in the fact that it's the desire to understand the world, the desire to make tools to make ourselves better. It's really totally human, the natural continuation of what humans are. That's how we like to think about AI and machine learning here at Amii. It's a really good frame of reference as we go through the rest of this presentation. AI and machine learning are tools for us, and that truly, as humans, what we do is build tools. Amii, we are one of the 3 AI centers of excellence across Canada as part of the Pan-Canadian AI strategy, which was launched in 2017. And so the other 2 institutes across Canada are Mila out of Montreal and the Vector Institute in Toronto. And since the beginning of the Canadian AI strategy, where we were spun out of the University of Alberta as a not-for-profit, Amii has really been here to help build internal AI capacity with industry and companies just like yours out there. And we like to play a broker role between industry and academia, where we're able to help both sides of the equation, help industry support academia, and help academia and the research help support industry in that virtuous circle. We really like to be there and support both sides and create that circle. And here at Amii, we work to move organizations along our AI adoption spectrum. So we work with you to integrate AI and machine learning into your organization in a successful and sustainable way. Something important here is that not everybody or every company is going to be starting at exploring and going all the way along the spectrum and to advancing. Some people might start in one spot and end earlier. That's okay. What we're really here to do is to help you go from where you are to where you want to be in your AI and ML adoption process. We often see that, though, that the companies that see the strongest gain in competitive advantage in the stages of implementing and operationalizing AI and machine learning. All right, well, I'm going to bring James up to talk about what is machine learning.
So the machine learning process generally starts with an important example, something that you really need an answer about. Maybe it's incoming email and you want to know whether or not it's spam. Or maybe you have some type of machinery and you want to know the probability that it's going to fail in the next week. Whatever this is, it's something that you want an answer. So you send this into some type of ML system. Maybe you haven't really thought about it being an ML system, but some example is going into some system. And out of it comes some helpful answer. Maybe it says that this email doesn't look like spam, or there's a 73% chance that the machine will fail this week. So what happened there? Well, it's magic, of course. Some magic turns this important example into a helpful answer. But of course, it's not really magic. It's a QAM, a question answering machine. Now that term, QAM, is not a standard term. It's one we use at Amii because a lot of industries have an idea of some sort of model, and that can mean different things. So we specifically talk about a question answering machine as this machine learning system that can turn an example into some type of answer. So I'm going to take this diagram and flip it up on its side. So what's the process for building out this QAM? Well, we need some type of learning data, a big pile of data. The amount you need depends a lot on the specific problem that you're trying to solve, but the main thing is there's going to be a whole lot of data. And another thing that's important about this data is it needs to be as similar as possible to the data that will be coming in. If you're trying to identify whether a photo has a cat in it, then you need to make sure that your learning data contains pictures of cats in all sorts of different poses, cats that are fluffy, cats on fire trucks and ambulances, whatever types of different pictures that you can add that are similar to the new images that you're going to be seeing. So then you're going to throw all that learning data into a learning algorithm, and that learning algorithm is going to build out your QAM. And so that whole phase of taking the learning data into the learning algorithm to build a QAM is called the QAM development phase. And that phase is prior to deployment. That's just for building. Then the phase after that is when you go into testing, into production, you put out the QAM and actually see how well it's working. So all of that together, that's the science of machine learning. That's the technical process that scientists like me get really excited about. But it's not enough. You're running a business, you need to make sure that there's business value. You want a competitive advantage. So in addition to this whole section about the science of ML, it's important to consider the business of ML. And the business of ML, that includes a judgment call of some sort. Let's say you think it might rain today. Well, you have to make a judgment call about at what probability of rain are you going to be concerned. Maybe you say 30% chance of rain. And then what's the action you're going to take? Probably to take an umbrella. And then the outcome here is that your clothes don't get wet. But the judgment call, the action that you take, and the outcome, these are all specific to the context of your business. So if you take all these things together, your business of ML and that science of ML, together that produces the learning process for competitive advantage. This is what makes your machine learning system so solid. So now I'm going to hand things back to Adam to talk about AI, ML, and data science.
Awesome. Thanks, James. We often get asked what is the difference between these three areas? What is the difference between AI, machine learning, and data science? And the truth is that there's a lot of overlap between these three different disciplines. As you can see, AI is a big encompassing field where machine learning is a subset of it, and a subset within the study of AI, artificial intelligence. Data science, on the other hand, has a lot of overlap with both AI and machine learning, but does have some field of study outside of the area of those two fields. So you can see that kind of demonstrated visually in this Venn diagram here. Diving a little bit into what we really mean by each of these. AI is really about enabling computers to be intelligent, whereas machine learning is using data, algorithms, and computations to enable machines to learn. Data science, on the other hand, is really the study of making sense of that data. And like I said, that can be a part of machine learning and AI, but it doesn't have to be exclusively within those two fields of study. Now, what can machine learning actually do? We have these tools. James talked about the process of building machine learning, but what does it actually do for you? If you build this tool, what can it do? Well, I really like to think about machine learning as doing tasks for you. There's some really major tasks that machine learning can really help you with. And there are these three right here. So predicting a class or value, identifying groups and outliers, and optimizing actions. These are the three main tasks of machine learning. And we are really going to dive into in detail what all three of these areas are, how they're used in Edmonton, and some cool local examples, as well as what happens when these tasks fail, when machine learning fails at these tasks, or does these tasks in a way that is unintended by the person programming them. But before we dive into that, these aren't really the technical terms when it comes to machine learning. If you're familiar with machine learning, you've probably heard these three tasks described in a slightly different way. So I just want to start with that. We often hear predicting a class or value called supervised learning. We often hear identifying groups and outliers as unsupervised learning. And optimizing actions is often referred to technically as reinforcement learning. So like I mentioned, these are the three main fields of machine learning and the three main tasks that machine learning is able to help you with. And so now we're going to dive into what each of these are, how they're used in Edmonton, and what happens sometimes when they fail out in the real world. All right, James, we'll bring you back on for some supervised learning.
Supervised learning is an extremely common approach to machine learning. And I'm going to talk today about it in two general categories: predicting a class or predicting a value. So let's say you have this picture of an animal on the left here, and you ask the QAM, the machine learning system, what class of animal is this? And it will pick one of these categories or classes. So in this case, it'll say, well, this is a bird. But sometimes it's not just a class that you want to know. You might instead have a picture of a dog. And you give this picture to the system, and this time you want to know how much does the animal weigh. And the system says, well, this dog weighs 36 kilograms. And so these two options, predicting a class or predicting a value, tend to be the ways that we do supervised learning. So now Adam is going to talk a bit about some Edmonton examples of companies that are doing supervised learning.
Awesome. Thanks, James. So the first example we wanted to talk about is Meadow AI. So this is a great example from right here in Edmonton of a company that's using supervised learning to predict a class or value. So if you're not familiar with Meadow AI, they have the world's first FDA-cleared AI platform that makes ultrasound workflow faster, more reliable, and accessible to everyone. Their platform is really designed to analyze ultrasound images and to help detect if there is a presence of disease or what level of disease potentially is in an ultrasound image. So this tool, their first product with this was around hip, so Meadow Hip, which is looking at infant hip dysplasia. They've now also built out several other tools using the same technology, including Meadow Thyroid, Meadow Lung, and Meadow Viewer. So really cool examples here being utilized all around the world. And then another Edmonton example is Fredible. So Fredible is another awesome Edmonton company using supervised learning. And I like to think about Fredible as kind of like Siri, but for music, when you're playing music, where you can play your instrument anywhere, anytime, and their expert AI will write the sheet music and the MIDI document for you based on what you're playing for them. It can be used on your desktop, your web browser, or any other platform. And it's really cool how they're able to use this to detect in this case, the note that's being played. That's the value that they're helping to determine. what note is being played so they can record it on the sheet music for you and for the musicians as part of their program. Now, what happens when these systems don't work as planned, or how do they work maybe in weird ways? Well, the example here we have is example of a system that describes images. So you can see in the first line where it says number 1 that the system is looking at the image and identifying different pieces of that image. So it's flagging and putting a box around different pieces. You can see a crowd, you can see a woman, it's identifying purple, camera, and obviously a cat on this lady, as you can see. So, I don't know. I'm not seeing a cat, but the system for some reason is seeing a cat there, which is kind of one of our first flags. But then the system is looking it through and it's generating sentences based on the keywords that it's identified in the image. So you can see a purple camera with a woman, maybe not, a woman holding a camera in a crowd, that seems a lot more accurate, as well as a woman holding a cat. So again, that cat keeps coming up, and I'm not sure where it's hiding in that image, but there's definitely not a cat in there. And then the system ranks the sentences based on what it thinks is the most accurate depiction of that. And we get a woman holding a camera in a crowd, which is how I would describe that picture. But the interesting thing about this is that if you look, holding, where it's pulling the word holding from, is from the woman in the background, not the woman in the foreground. So even though the woman in the foreground is the woman holding the camera, it's picking up parts of the image from her, parts from the person in the background, and putting it together. So it's getting the right answer, but in a kind of a way that a human wouldn't traditionally analyze it. Another one here, we have examples like this. So on the left, the caption reads, "A cat sitting on a toilet in a bathroom." It doesn't look like any cat or bathroom or toilet that I've ever seen. And the image on the left is very obviously an image from Tony Hawk Pro Skater, or maybe not, as it says, "A man riding a skateboard on a ramp." Well, I don't really see that there, but that's all right. So my point here is that machine intelligence is not human intelligence, and sometimes systems can fail miserably and hilariously in ways that a human never would. We have one final fail here for image captioning. Sometimes it can detect things that aren't there. So think back to the cat that was in the first image. In this one here, it says that this is a field full of sheep. There are no sheep in this picture whatsoever, but the system was trained on images of green fields and green pastures with sheep on top of them. And so it associates green pastures and hilly areas with sheep. And so even though in this picture there are no sheep, it's thinking there are because of the data that it was trained on. All right, let's jump over back to James for unsupervised learning.
Unsupervised learning is a process of looking for groups in your data, or outliers. So let's say you've plotted a whole bunch of dots like this, and you want to know if some of those dots seem to be more associated with one another. And now as a human, you might just go and draw a circle around one of the groups and call that a cluster. Maybe you look at another dot somewhere and see that it doesn't belong with the others. That's an outlier. So you can send this into a machine learning system and get that type of result. And it might, in this data, circle all three of the different groups. And then it's really clear in this image that there are 3 groups and 2 outliers. And the really powerful thing here is that as a human, we look at this simple plot. It's really easy for us to tell what's going on. But if there were, instead of 2 dimensions here, if there were tens or hundreds of dimensions of data, it's no longer possible for a human to process that much data all at once. And yet the machine learning system can do that. So Adam will tell us about a couple of companies here in Edmonton that are processing massive amounts of data like that.
Awesome. Thanks, James. So yeah, like James mentioned, it's easy for us to, as humans, to look at this when we're talking about 2 dimensions. But what happens when you're talking about, James mentioned 10 dimensions, 100 dimensions? What about billions of dimensions. SamDesk is a local Edmonton company that is doing it at a scale in the billions. So their system is able to scan through billions of social media posts every single day and identify when disruptive events are taking place, things outside of the ordinary, those outlier events that James was talking about. It's able to then identify those, evaluate their credibility, and then pass that information on to their clients around the world. You can think of Sam's real-time knowledge engine as your very own AI assistant in this, where it's able to distill world events into a credible stream of information for companies, news agencies around the world. You'll be able to also check out a full presentation from one of the engineers at SamDesk at our AI meetup tomorrow evening. So that's going to be taking place tomorrow evening at 5 o'clock. And SamDesk will be one of the presenters at that meetup. Another Edmonton example using unsupervised learning is Improbotics, which is a tech-infused improvised theater comedy show. That is a lot of really cool words all in one sentence. So they're using a live Turing test-based scientific experiment within this. And how this works is they have an actual AI-based chatbot that is performing in the show with real live humans. And it is actually sending some of the actors and some of the improvisers words, phrases to say and to incorporate into their improvisation, which makes it very hard and hilarious as the performers are trying to incorporate this into their presentation and into their scene that they're generating, especially when sometimes it makes no sense at all what the system is trying to tell them to do. I've seen this their show live a few times, and it is hilarious. And I really recommend checking it out if you have the opportunity to do that. All right, let's pass it over to James to talk about what happens when unsupervised learning can fail.
Let's say I asked you, a king is to a man as a queen is to you'd probably think a woman. Or if I asked you, a screw is to a screwdriver as a nail is to a hammer. It turns out you can ask an AI to answer the same type of questions. You get it to understand the concepts of words as vectors. Each word is represented as an arrow that has a direction and a length. And then you can do math with these. You can say, if I take a king and I subtract out the concept of a man and add in the concept of a woman, then it figures out that, oh, well, this is pointing to queen. So this is really cool for understanding word relationships. You can get some interesting things out of it, but it can also reveal some problems. So let's say instead I asked you, a man is to a programmer as a woman is to a, well, you're probably going to say a programmer. That seems pretty clear. But when you ask the AI, man is to programmer as woman is to a housewife, well, that's not the answer we were looking for. And this illustrates a case where, like, sometimes fails can be funny. Sometimes fails reflect back to us something maybe a little uncomfortable about society. In this case, the AI has picked up on the bias in English language, in writing, across decades or centuries. And when that data was used to train the AI, it learned to pick up the sexist bias in that underlying data. And so we see that in this system. Now, the good news about a system like this is that you can actually train out that bias. You can teach it to understand the concept that sister and brother are gendered terms, mother and father are. It can even figure out that ovarian cancer and prostate cancer kind of belong in different categories. But it learns that it's not appropriate to consider a programmer to be a gendered term. So it's cool to see sometimes these biases can be corrected. Our third category here is reinforcement learning. This is a really interesting category because it's not just about taking in an example and getting an answer out, but it can actually dynamically respond to its environment. So if you look in the center here, there's this little bug, a brain with a microchip on it. That represents the agent or the AI. And it receives information from the environment that it's in, sensors or video feed or something to understand what's going on. And then it gets to take an action, something that actually affects itself and the world around it. And based on whether it's done a good thing or a bad thing, I can give it a reward or a penalty. And based on that, it learns what it should do. So the next time it gets information from the environment, it can choose to take a different action. So when these agents learn to do these things, they can start to pick up on what's going on. They get smarter over time. As you can see in this video, there's this agent that's learning how to walk, and it's a little bit wild, but it's figured something out. They can learn to jump and duck and run. And this is something that actually the University of Alberta is very well known for. This is something that a lot of Amii researchers focus on. This is really a local strength. And so this learning to climb over things and act as agents is a really interesting thing that can also be applied to startups. For example, there's a group working here in Edmonton on the Drayton Valley Water Treatment Plant. And the goal of this project is to understand the power usage of a plant and optimize that, or to see what chemicals are being used and see if we can reduce the amount of chemicals that hit the water system, or to look at water cleanliness and see if we can get cleaner water. So the agent here is dynamically adapting to the incoming water quality. It could adapt to energy prices to get the best, cleanest, lowest cost water possible. Another example out of Edmonton here is the Blink Lab, which works on prosthetic limbs. Their aim is to help when someone needs some type of prosthetic and maybe they have a limited amount of control. Traditional prosthetics often don't do a lot more than like open close actions or very simple things. And so this lab is using reinforcement learning to be able to take more diverse actions or predict what a user might need and really help and assist them. So it's really cool to see these ways that reinforcement learning works, that it's being used locally, but sometimes it doesn't work out so well. If you think of this example here of, you can see this stick figure of a cheetah in the top right corner that is learning to walk. I let it control its limbs, and here's what it does when I send it out to try to run. Its reward is running as far as possible, and it's definitely doing that. This is clearly not what it's intended to do. Some type of backstroke on the ground, that's an RL failure. Or another example, in this video, there's a boat. And what the boat is supposed to do is win a race. As fast as possible, complete the race. Instead, it's learning to get as many points as possible because the ML developers who decided to figure out how to train this boat thought that the best way for it to learn to get a high score in finishing the race fast was for it to try and optimize the number of points it got. So it found these green power-ups that you can see it driving through, gave it a lot of points. So instead of doing what seemed obvious to the human, just finishing the race, it just drives in circles forever and collects as many power-ups as possible. So you got to be careful about exactly what you tell your agent to do if you want it to work properly. Now I'll hand things back to Adam to talk about what you can do if you're looking to use some machine learning or AI in your company.
Awesome. Yeah, so now so far we've taken you through a little bit about Amii. We talked about the different types of machine learning, what they can do, how they're used, what problems they're able to solve, how they're being used right here in Edmonton. And we've had some fun examples of what happens when they're not working as expected. But so if that's inspired you to try and figure out how can you use AI and machine learning at your company, at your startup, you want to learn a little bit more, this next little section is for you. So we have some programming right now that is available for companies to register for. So we have our Supply Chain AI West program that has applications available right now. Our applications are open today. So this program is for startups who are building or plan to build AI and machine learning that will directly impact the supply chain. The supply chain areas that they're looking for impact on are around planning, sourcing, logistics, production, sales, after sales, really runs the whole gambit. So any part of the supply chain, if you're currently building or planning on building an AI or ML solution that'll be impacting one of those areas, I definitely recommend reaching out and setting up a call with us to learn more about the program. Overall, the program is an 8-month program broken up into different month-long sprints, and we really focus in on providing hands-on coaching and support for your companies throughout that process. Like I mentioned, applications are open right now. I also wanted to give you a little tease of some programming that'll be coming and made available in the coming months. So this is stuff that we're building right now. We've been piloting some of these programs, and we're building out these programs and resources to help startups like yours go from exploring to building to commercializing AI and machine learning technology. So we have our ML exploration program, which is for early stage or companies that are early on the AI adoption spectrum. They're kind of exploring, trying to figure out if AI and machine learning is right for them right now. This 2-hour program is a 2-hour program where you learn about AI, machine learning, what it can do, what it can't do, what you shouldn't do with it. But what we really focus in on is generating machine learning problems that have business value. Because like James mentioned earlier, if the machine learning problem doesn't have business value, it's not worth your business solving it. Then we have our machine learning problem mapping and evaluation workshop that we're piloting right now. And this is to help you generate more machine learning problems or questions, evaluate them, and help determine which ones are going to be right for your company to start building out a quam to answer. And then finally, we're working on a membership model as well to help engage startups at various levels, startups that are new to machine learning, but startups also who have a high level of expertise in machine learning to help engage a whole community here in Edmonton and across Western Canada. So like I mentioned, those programs are where you're just getting a sneak peek right now, but they'll be made live and available to the public in the near future. But outside of their programming, how can you get involved with Amii? Well, number one, you can check out our 2020 Impact Report. 2020 was an amazing year for Amii, and we really want to share that with the city and with the province. So check that out. There's a lot of really cool stories in there, something that might inspire you. You can book a call with a startup team. We'd love to chat with you about your company, how you're currently using machine learning, or where you might see machine learning impacting your business in the future. You can also check out other Amii events at Startup Week. So like I mentioned, we have our AI meetup happening tomorrow night at 5 o'clock. We also have our AI seminar with the University of Alberta happening on Friday at noon. And we have a speaker from Meadow AI speaking at that. So that'll be a really great session as well, in addition to the meetup where we have Samdesk and Areto Labs speaking. And finally, you can sign up for the Amii newsletter on our website. This is a great opportunity to stay up to date with everything that's happening at Amii, as well as keep your eye on all the new programming that I mentioned. If once it gets announced, it'll be sent out in our newsletter for sure. So with that, I want to thank you for listening to our presentation. James and I would love to take any questions you have. I know that there are some questions in the chat, so I'm going to take a look at that. In the meantime, while I'm pulling up those questions, though, you can see the QR code on the screen. Feel free to take out your phone, scan that QR code. We'd love to get some feedback from you on our session and hear what you liked. Or what maybe could be improved for next time. So definitely take a scan on there. It only takes 30 seconds to do that quick little bit of feedback. But with that, I do have a question here. So I'm going to bring James on stage here. So it looks like Jess had a question. It looks like a two-part question. So I'll put the first part up on the screen here. So Jess asked, have a data set with highlighted numbers and non-highlighted numbers. there's a pattern within the highlighted numbers. For instance, when 3 and 5 are highlighted, then 7 cannot be highlighted. James, would you recommend, do you have a suggestion for the type of intelligence that we would use for this system?
If that's strictly based on rules, then it's better to code in those rules. It would depend a lot. I think I would need more information to really get into that. But if you're saying that there are specific expectations you have for the data, then that would fall within supervised learning if it fits within one of those 3 categories.
Cool. And Jess, I hope that answered your question. I see you also had another question here a little while ago about if it was in person or online. I'm not entirely sure what you're referring to here, so feel free to throw another question or comment in the chat if you want to just give us some clarification on that. But other than that, if anyone else has any other questions, we'd love to answer them. We'll give it another minute or so before we wrap up, and we'll see if Jess has an answer to that question. So, I think you had a follow up to his last question, or the last question there, James. So throw that one up while they're typing the other one out. So I do not have the rules. Just trying to understand the rules behind the highlighted numbers.
Yeah, in that case, if it's trying to, there may be some clustering involved if you're trying to figure out which of these are more similar to each other, and that can maybe help reveal some of the relationships and why some of this highlighting is going on. Whereas if you're trying to predict what should be highlighted in new sets of numbers, then supervised learning is a lot more useful because that's going to predict what to expect. But generally, if you're trying to understand the rules behind something, unsupervised learning can help with that. I often think of that as more strongly leaning into the data science toolbox, because data science is often more about trying to understand and kind of dig a little deeper into what's going on.
Awesome. Thanks, James. Jess, I see that you asked, clarified that was for the AI meetup, the in-person or online. So our Amii AI meetup will be taking place online. You can check out our events on our amii.ca or through Startup Week, the Startup Week website. You can find the link on there as well. But yeah, it will be taking place online tomorrow at 5 p.m. And then we have a question from, that's from Zhao. Yeah, AI meetup is online. Perfect. From Sheldon, how far away are we from artificial general intelligence? I don't know, James. Do you have an insight there?
It's something that always feels really far away, and then it can feel really close. But I think that's pretty well impossible to predict. If you asked a whole bunch of experts in the field, some of them will give you very, very short terms, and some will give you really long terms. But I definitely don't have a guess for that.
So what you're saying is we don't know how long it'll be until I have Jarvis in my pocket running my whole life for me.
Yep.
Awesome. Well, I don't see any other questions out there. So I will wrap it up with that. I really wanted to thank all of you for joining us today and for this presentation. We really enjoyed spending some time with you this afternoon. Again, check out the other Amii AI events that are happening tomorrow and Friday. I know I'm really excited to see everybody at Launch Party on Thursday. So thank you to Startup Edmonton for having us this week. Thank you for putting on Startup Week here in Edmonton. We're really excited to be a part of it. And we will see you all at one of those other events later this week. Bye, everybody.